We're going to be looking at the concept of absolute value, not necessarily the absolute value function, though I'll link a video about the absolute value function below, but first we've got to see what does the term and the concept of absolute value mean. So let's get started with this statement. The square root of x squared is equal to what? Now, instinctively, if you have not been working with any of these concepts of absolute value, you would want to jump in and say, well, the square root and the square cancel each other out, so the square root of x squared is x. But this is a trick question because this is not true. That answer is not x. So let's take a look at some actual examples. If I want the square root of 5 squared, well, we're asking for the square root of 25, and we know that is 5. But if I ask for the square root of minus 5 squared, I'm asking for the square root of 25, which is still 5. So if I look at the square root of x squared, so let's just say the square root of something squared is not necessarily that something. The square root of 5 squared is 5, but the square root of minus 5 squared is not minus 5, it's 5. So just be reminded, if I'm presented with a square root and there's no sign in front, we assume that it's positive. So this means the square root of x squared will always result in something positive or 0, because the square root of 0 squared is the square root of 0, which is just 0. But no matter what number I put in there, the square root of 9 gives me 3. The square root of minus 3 squared is the square root of 9, which gives me 3. I always end up with a number that's greater than or equal to 0. And that is the concept of absolute value of a number. So if I look at a number x in this case, we notice that if whatever is in there is 0 or positive, it spits out the same number, the square root of x squared. 0 spits out 0. Square root of 5 squared spits out 5. Square root of 3 squared spits out 3. But if I've got a negative number, it spits out the positive version of that number. So if I've got the square root of minus 5 squared, I get 5. The square root of minus 3 squared gives me 3. So whatever that number is there, it's this square root of that number squared gives me something positive. So how do I make a negative number positive? Well, we multiply it with a minus 1. So if I now formalize the definition of absolute value, I am saying if I've got the absolute value, and we'll get back to that number line shortly, if I've got the absolute value of a number a, I say leave the number alone. It's exactly what it was if that number is greater than or equal to a. What's the notation? This symbol stands for absolute value. So the absolute value of a, if my number was positive, greater than or 0, it stays the same. So that means the absolute value of 5 is just 5. The absolute value of 0 is 0. The absolute value of 3 is just 3. But the absolute value of a gives me minus a if that a was a negative number. So the absolute value of minus 5 is minus that number, which is 5. The absolute value of minus 3 is minus that minus 3, which gives me 3. So the absolute value always spits out a number that is either positive or 0. And this is the algebraic look at the absolute value. This is the definition of the absolute value of a function. If I look at the absolute value function, we can think of it as distance. How far is it from 0 to 3? Well, it's 3 units. If I have to travel from 0 to 3 on a number line. But if I have to travel backwards from 3 to 0, it's also 3 units. It's not exactly the same. The one takes me in that direction and the other one takes me in that direction. But the distance is the same. So if I have to calculate the distance, now these are simple numbers, but if I have to calculate how far does it go to get from 0 to 3, I would say it's 3 where I end minus where I started. But if I had to go from 3 to 0, where I end minus where I started, that gives me minus 3. But if I'm looking for the distance, I want to know how far it is. I'm looking for the absolute value of this number. And that will give me the same number and the same distance as 3. Similarly, from minus 3 to 0 or from 0 to minus 3. All the same distance. The calculations would be different, but as soon as I take the absolute value, I get a positive number or 0. So here's the definition for absolute value. So let's take a look at some properties of the absolute value. Now, we're not going to prove these properties, but some of them make sense if you think of what absolute value does to a number. So the absolute value of a number is always greater than or equal to 0. where a and b are real numbers for all of these. So that's how it's defined. It spits out a positive number or 0. And it spits out 0, so the absolute value is equal to 0, if and only if I start with 0. It's positive if my number was not 0. So if I've got a non-zero number, the absolute value of that will always be positive. Then, following directly from there, the absolute value of a minus b, no matter what happens inside those absolute value signs, my answer has to be positive, as long as a is not equal to b. Because if I've got the absolute value of 5 minus 2, I get the absolute value of 3, which is 3. But the absolute value of 2 minus 5 is the same as the absolute value of minus 3, which is just 3. So the absolute value, as long as those two numbers aren't the same, I will get something that is positive. And the absolute value of the absolute value is just the absolute value. So that makes sense, because the absolute value of the absolute value of a, whatever the absolute value of a inside here gives me something that's already greater than or equal to 0. So these outside absolute value signs will just say leave it as it is. So just leave it as it is. All right, so any number is always less than or equal to its absolute value. And if it's equal, that is when it's positive or 0. So if I've got a negative number a, the number, for example, minus 3 will always be less than or equal to the absolute value of minus 3, which makes sense because minus 3 is less than 3. But if I have a number there that's positive, then the absolute value of the number is just the number itself. All right, some more properties. It gets a little bit more interesting. The absolute value of minus a is the same as the absolute value of a. That makes sense. We've already looked at this one. The absolute value of a minus b is the same as the absolute value of b minus a. The absolute value of a squared is the same as a squared. And the square root of a squared is the absolute value of a. That's where we started this. The absolute value of a times b is the absolute value of a times the absolute value of b. We're going to look at that one a little bit more in detail shortly. And then the absolute value of a divided by b is the same as absolute value of a over the absolute value of b. Then we've got the triangle inequality. Now it's called the triangle inequality. If you take any triangle, you should know that if I add together the two shortest sides, that answer is always greater than or equal to the longest side. If I add together the two shortest sides, I'm getting something that's bigger than the longest side. And that's why it's called the triangle inequality. But what we say is the absolute value of a plus b is always less than or equal to the absolute value of a plus the absolute value of b. So it's linked to a triangle. All right, but let's just look at this one over here. If we look at this property, the absolute value of a times b. Now, if I want to prove, now we did not prove any of these inequalities or equalities or properties, but if we want to prove one of them, what we'll have to look at is some different cases. We'll have to look at the 0 case. We'll have to look at the cases where numbers are positive and where numbers are negative, because the absolute value behaves differently. So if I look at the absolute value of a times b, so let's take the case where a and b are both greater than or equal to 0. Now we know if a and b are both equal to 0, I'll just get a bunch of zeros. So that's a little bit of a boring case. But just to lay it out a little bit, and I'm not going to do the whole formal proof, but we have to look at the case where they're both positive. Where they're both positive, if a and b are two positive numbers or 0, then a times b is also going to be positive or 0, because I'm multiplying two positive numbers that are non-negative. So the absolute value of AB must then be equal, because it's a number that's greater than or equal to 0, will then just be AB itself. And also, if I look at the absolute value of A times the absolute value of B, the absolute value of A is greater than or equal to 0, so that just gives me A. B is greater than or equal to 0, so that's A times B. So I've shown for this case that the absolute value of AB is equal to the absolute value of A times the absolute value of B. But what about the case where A is greater than or equal to 0, B is less than or equal to 0? So if one of them is positive, one of them is negative. Now, without loss of generality, I don't have to look at A negative and B positive. I can just look at this case. Then A times B, if I multiply those two numbers, I'll get something that's less than or equal to 0. So the absolute value of AB is going to be minus AB, because I've got something negative inside there. Then if I look at the absolute value of A times the absolute value of B, A is positive, so that'll just be A. B is negative or 0, so that'll be minus B, and that gives me minus AB. So we can see that the absolute value of A times the absolute value of B is equal to the absolute value of AB. There's another case. That is when both of them are negative. Now I'm including 0 here. We can do a separate case for when one of them is 0, but 0 does not really make a difference to these. And then you can do the same process to see what happens. So I'm not doing the whole proof, but that is basically how you're going to look at showing these properties. So just to wrap up this video, that's what we looked at now. If we just use these properties in the definition to do some quick calculations, the absolute value of minus 4 plus 3 is the same as the absolute value of. The absolute value of minus 4 is 4 plus 3. That's the absolute value of 7, which is just 7. Absolute value of minus 22 plus 5 is the absolute value of minus 17. Plus the absolute value of 5 minus 3 is 2. So that gives me 17 plus 2, which is 19. Absolute value of 4 times minus 3, that's the absolute value of 12. So that gives me, or minus 12, that gives me 12. Minus 14 divided by 7 is minus 2. The absolute value of minus 2 is 2. So it's 12 minus 2, which gives me 10. So that's how calculations can get more complicated, but that wraps up properties of the absolute value and its definition. In the next video, we're going to look at solving equations and inequalities with absolute value.